In this video, we will talk about inverse of a matrix. We have two examples here. The first one, use the inverse of a matrix to solve the linear system. We have here linear system. Here, as we have discussed before, you can represent this system as AX equal to B. So here, so this system, it can represent as AX equal to B. As we discussed before, you can write it as augmented matrix. Then from augmented matrix, you can solve it. But here, we will use the inverse of a matrix. So now it's clear that you have to find the inverse of this A. So if you find the inverse of this A, then you can solve this by multiply A inverse for both sides from the left. It has to be from the left, not from the right. So it has to be here and here from the left for each side. Then if you multiply, then you will get X equal A inverse multiplied by B. We will review all of these in a moment, and we will dive in how to find the inverse of a matrix, and also to understand what is AX equal to B and CX, for example, equal to 0. So just to make it clear here, we have here this equal to B. B, it's mean these numbers, but here we have 0 in this system. So here in this system, it has 0, 0, 0. So now let's read the second example. Let C equal to this matrix here, 3 by 3 matrix. The same here, we have 3 by 3. I will write everything here just in a moment. Find if possible C inverse. Does the linear system Cx equal to 0? This is as a linear system. It's similar to this. So you can write exactly, you can write this one to look like this. So just you have to put the coefficient, then you can write it like this. So we have to answer this question, does the linear system Cx equal to 0 have infinitely many solutions, or they called it non-trivial solution? To answer this question, we have to find, if possible, this C inverse. So if it's C inverse exists, then we can decide what type of the solution here. But we will review all of these up, but you have to know if C inverse exists, then it has to be a unique solution, or they called it only one solution, or trivial solution. But for infinitely many solution, they called it non-trivial solution. Everything we will discuss up, but just to make it clear, here, this question, example 2, is straightforward because they ask find if possible C inverse. But here it's not straightforward. It's look like mysteries how to find the inverse. But if you write it like this, now it's clear for you. You have to find this matrix. You can call it B, C, D, or any letter, but it has to be capital because here is the big matrix here. It has to be big matrix, but here it's represent as a vector x1, x2, x3, so it has to be vector, and this one it has to be vector as we have discussed before. So here, where A equal to this matrix 1, -1, -2, 1, -1, -2, and the row here 0 here, because here there is nothing here, so it's like 0 multiply x1, so here 0, so here 0, 1, 2, 1, 2. Sometimes they don't put it like this, but you have to rearrange them to be like this. So x1 here, x2 here, x3 here. You have to write them like this if they put not in order. For example, let they put here x2 here, so you have to shift it to here. So you have to write them like this. So each variable here, x1, x2, x3, and here is the number. Sometimes they put here x1, so you have to subtract both side of this equation, then you have to get here the number. So here 1, -2, -3, 1, -2, -3. Now I will close this bracket. Then I will write x, which has to be x1, x2, x3, x1, x2, x3. B, the results here. Now I think it's clear for you where is the inverse. The inverse, it's here. We have to find A inverse. What is A inverse? So we have to find A inverse. It's look like this. So we have to find A inverse and this. So here I want to review about what is this definition. So if A inverse exists, then A multiplied by A inverse equal to A inverse multiplied by A equal to identity, which is, as we discussed before, it's similar to, for example, number here 3 multiplied by 3 power negative 1, which is equal 3 multiply by 1 over 3, because this is exponent, so I wrote it like this. Then this one, it goes with this one. Here the answer it will be 1. And the same thing, if you multiply here 3 power negative 1 multiply by 3, so if you change this order, you will get the same answer here as 1. Here this, it's not exponent, so here A inverse, it's not exponent as 1 over A, because all of these are matrices. But the relation between this and this is that if you multiply A multiplied by identity, you will get the same A. So here, if you multiply here 3 multiplied by 1, you will get 3. The same thing here. So if you multiply A multiplied by identity, you will get A. So the same thing here, the same way here we write it. So identity here, any matrix here, any matrix multiply by identity, it will remain the same. So it will remain the same as A. So it will not affect anything. So this is the concept behind this. So here it will look like this in the same sense, but just to make it clear, here matrices and here numbers. Now let's clear all of these. So just in general, if you have any matrix, so I write it square here, multiply by its inverse, it's equal to this inverse multiplied by the matrix equal to identity. This is the general idea for this. So if you multiply matrix by its inverse, it's equal to its inverse multiplied by matrix equal to identity. So you have to know about this thing. Now let's review about how to find the inverse. As we discussed before, to find A inverse, you have to write it as augmented matrix, and any operation you apply on the left side, you have to apply as well on the right side. Then if you apply RREF, which means that you use elementary row operation, there are 3 types of row operation, which are row switching, row addition, row multiplication, which we will use it later. If you can transform A by reduced row echelon form to identity, then in this side it will transform to the inverse of A. And of course, if you want to back again, of course, if you go from here and you make it identity, this it will change to A inverse, then you can back again. To back again here, so if you put here A inverse and here identity, you can back again to identity by reduced row echelon form, and this side it will back to A. The important note here, if you can transform A to identity, then A inverse exists, which is very important to solve the system. So if you can transform it to identity, we know from before that a unique solution can transform to identity, but infinitely many solution, no solution, they cannot transform to identity. So that's why here we will say here A inverse, here A inverse does not exist, does not exist, does not exist. But here and here we will say A inverse exists because of this. So if you can transform, and also you can see here F and only F. So if you can transform A to identity, then A inverse exists. Of course, if you back again here, if you have A inverse exists, then you have to know that A can transform to identity. So here we know as before from types of solution, here this a unique solution, this a unique solution can transform to identity. So here we can write here, I will explain in detail in a moment. So here A inverse exists. And the same thing here for Ax equal to 0 here, the homogeneous system, here non-homogeneous system, here A inverse exists. The second important note here, if you cannot transform A to identity, then A inverse does not exist. So here in this one, we know that infinitely many solution, it has a 0 row, and the same thing here, no solution, it has a 0 row from the left, but from the right there is a number which is non-zero, so that's why it's no solution. But here we don't have no solution. If you have Ax equal to B, you have only 3 possible solutions, but if you have Ax equal to 0, you have only 2 possible solutions. So here, infinitely many solution, we have A inverse does not exist. Here, the same thing, A inverse does not exist. Here, A inverse does not exist. I can repeat here again as before in some videos, a unique solution in Ax equal to 0, they called it a trivial solution. They prefer to say a trivial solution. For infinitely many solution, they prefer to say non-trivial solution if we have Ax equal to 0. Just, I want to remind you this, sol mean solution. Okay, let's go a little bit down. So here, to make clear why here we have A inverse exists, just I want to remind you as before, here this a unique solution, it's look like this after apply RREF. Let's say you have here 3 by 3, so it look like this, 1 0 0 0 1 0 0 0 1, and here line, the augmented, and here let's say here you have 0, and here you have 4, and here you have -2, for example. You can see here you have leading 1, leading 1, leading 1. So here it's look like identity matrix 3 by 3. Just to remind you here, after apply RREF. So you can see here, if you can transform A to identity here, of course, after apply RREF, if you have a unique solution for Ax equal to B, as we discussed in some previous videos, it's look like this. So you can transform it to identity. Therefore, A inverse exists. For here, infinitely many solution, the solution it look like this: 1 0 0 0 1 0, and here you have a 0 row, and sometime you have 2 0 rows, but just to make an important note that here you have 0 rows. Here, let's say you have 3, -1, and here it has to be 0. Because if it's not 0, then it will be no solution. So here you have a 0 row, so you cannot transform it to identity with size 3 by 3. So here, as we discussed here, it's 3 by 3 matrix. So here, after apply RREF. So after apply RREF, you will get like this. Then you have to know that A inverse does not exist. The same thing here for no solution. You will get the solution look like this, which is similar to this one, but here it has to be a number here and no solution. So 1, 0, 0, 0, 1, 0, 0, 0, 0, and here the line of augmented, and here it has to be any number. So let's say here you have 2, and here let's say you have -3, and let's say here you have 0. So here we have the solution to look like this, and of course here this side it's not equal to identity with size 3 by 3. So that's why here A inverse does not exist, because if you apply RREF, then you will get like this, which is not like identity matrix with 3 by 3. Let's change the color. And the same thing here for AX equal to 0 for a unique solution, which is exactly like this one, but here 0, 0, 0. So let's write it here again. 1, 0, 0, 0, 1, 0, 0, 0, 1. Line of augmented here, 0, 0, 0. 0 here, it's mean 0, 0, 0. It's not only 0 number. So it's mean a vector of a zeros. So here we have leading one, here we have leading one, here we have leading one. So here it's equal to identity with size 3. So that's why A inverse exists, because you can transform A to identity. But here and here, you cannot transform it to identity. Therefore, A inverse does not exist in both here, and of course here as well. Let's change the color. So here for infinitely many solutions, exactly like this one, but here they have to be 0, 0, because here 0. 1, 0, 0, 0, 1, 0, 0, 0, 0, line of augmented, 0, 0, 0. Let's change the color. So here you can see here we have a 0 row, and this is this side here. It's not like identity. Of course, after apply RREF, reduce row echelon form. So this form, it's not equal to identity after apply RREF. So here after apply RREF. So it's very simple here. I wrote here also important note: if A inverse exists, then AX equal to B has a unique solution, as we did here. So it's exactly as we did here. So here, if it's a unique solution, A inverse exists. And the same thing here, if you have AX equal to 0, which is this system, has a unique solution, or they called it a trivial solution. A trivial solution here, as you can see, you can transform it to identity. Therefore, A inverse exists. So just to remind you, as before, a unique solution, it's called a trivial solution. They prefer to say a trivial solution rather than a unique solution if AX equal to 0. They like to call it non-trivial solution rather than infinitely malicious solution if they have AX equal to 0. So that's it here. Now let's go a little bit down. So here the second important note, if A is not a square matrix, then A inverse does not exist. So let's say here you have A equal 3 by 4, then from the size, you can say that A inverse does not exist because it's not a square matrix. So it's very simple. So what's mean a square matrix? Let's change the color. A square matrix means numbers of, here mean number of to make it clear for you, which is very simple to write it. Here this hash, I want to represent it as number of rows equal to numbers of columns. For example, let's put example. Let's say you have here A. It has to be 2 by 2, the size here, or the order, or they called it dimension, or 3 by 3, or A equal 4 by 4, and so on. So this equal to this. As you can see here, this 3 equal to 3. So a square matrix, the number of rows here, number of rows equal to number of columns. I hope this is clear for you. Now, example for how to use A inverse. How to find A inverse. To find A inverse, if A inverse exists, to use it, for example, in AX equal to B, we can multiply both sides from the left here by A inverse, because it exists, so we can multiply A inverse for both sides from the left. But just to remind you, if you multiply from the left here, you have to multiply here from the left. And the same thing, if you multiply from the right here, for example, here you multiply by A inverse from this side, you have to multiply here and this side A inverse. But here, since we are interesting, because we know from the definition that if A inverse exists, then A multiplied by A inverse equal to identity. The same thing here. If you multiply by A inverse, it will be A inverse multiplied by A, like this. A inverse multiplied by A, it will be equal to identity. So this very, very important definition here. You have to keep it in your mind in linear algebra because it's very important. So here we want to multiply from the left by A inverse from both sides. So A inverse, because we multiply here by A inverse, then AX equal, since we multiply here by A inverse, so we have to multiply here from the left A inverse, multiply by B. Then, as you can see here, A inverse multiplied by A, I will put bracket here, which is equal to identity. I will change the color. So here I will write here identity with size n. Here, because here identity, that's why I write here identity, and here we have x equal, and for this side we have A inverse multiplied by B. A inverse multiplied by B. Then, as we know that any matrix multiplied by identity, it will remain the same. So it will not affect anything. So here, identity multiplied by x, it will be x. So here I will write here x equal A inverse multiplied by B. This is the answer. Here is the answer. x equal to A inverse multiplied by B. So the answer for this, to find x equal to A inverse multiplied by B. For this homogeneous system here, Ax equal to 0, the same thing, we have to multiply from the left by A inverse. Exactly the same process as here, but here we have 0. So from the left we multiply by A inverse for both sides. So here we will multiply by A inverse. So A inverse multiplied by this Ax equal A inverse multiplied by 0. Then I will change the color. This here, we know because A inverse exists. So here it will be here identity. So instead of this, we will delete this one and we will write identity. So here identity. And here we have here x equal A inverse multiplied by 0, which is 0, because anything multiplied by 0, it will be 0. Here 0, it's a 0 vector. Anything multiplied by a 0 vector here, it will be 0. So that's why here 0. So here any matrix multiplied by identity, it will remain the same, which is x. And here we have 0. That's why they called it trivial solution, because x, the vector of x equal to 0. But you can call it only one solution, or you can call it a unique solution. All of these are correct. So here we have x equal to 0. That's it here. I think now it's clear for you everything related about the inverse, especially with the system like this, Ax equal to B or Ax equal to 0. Now let's go down to solve our two examples. So here we want to solve number 1. This number 1 here, we want to solve it. So here we want to find the inverse of a matrix for this one. So we have to find A inverse. So we have to write it as augmented matrix in the augmented form, which is here identity 3, because here we have 3 by 3. Equal, I will write the augmented matrix here. So here A, I will copy this one here. So I will speed it up. I will write here the line of augmented. Then I will write the identity matrix with side 3 by 3. So here 1, 0, 0, 0, 1, 0, 0, 0, 1. Then I will close this bracket. So here we have here A, and here we have identity with side 3. It's very simple. So you have to apply RREF to transform this to be like this. Just to make it clear that you have to change this one to be look like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. So you have to change this one to be like this. And any operation you apply to this side, you have to apply to this side as well. Then if you can transform this A here to identity, then this side it will transform to A inverse. Just to make it clear what is RREF, RREF is like a stair or snake game. It's like taking a stair from up to down, from here to here. So here 1, here 1, here 1. So the rest of this column 0, the rest of the column 0 except here, and the same thing, the rest of the column here 0 except here. just to make it clear here, so you have to walk until you find a number here. Let's say here a number, then you have to make it 1. Then if you make it 1, then you have to make the rest of the column zeros. Then if you make the rest of the column 0, then you have to go one step down. Then you have to walk until you find a number. Then if you find a number, then you have to make it 1. Then if you make it 1, then you have to make the rest of the column zeros. Then if you make the rest of the column zeros, then you have to go one step down. Then you have to walk until you find a number. Then if you find a number, then you have to make it 1. Then if you make it 1, then you have to make the rest of this column zeros. So that's it. At the end, it will look like this. But if you have a 0 row, for example, let's say here you have a 0 row, then you have to switch it to the bottom. Then if you change it here, then if here 0 rows, then you will decide that you cannot transform A to identity. Therefore, A inverse does not exist, as we discussed here. If you cannot transform A to identity, then A inverse does not exist. It's very simple, so let's now erase this one. So we have to apply RREF to make this identity. So here we have already here 1, leading 1. So we have to make the rest of this column 0. So we have to make this number equal to 0. So 1 minus 1, it will be 0. So row 3 minus row 1, it will give us here 0. So row 3 minus row 1 in row 3. I will change the color. This row and this row, it will remains the same, so I will speed it up to write this row and this row. So row 3 minus row 1, row 3 here minus row 1, so 1 minus 1, which is 0, negative 2 minus negative 1, so here I will write it here, negative 2 minus negative 1 minus negative 1, which is here negative 2, minus with minus, which is positive 1, equal negative 2 plus 1, which is negative 1. So I will write here negative 1. Negative 1, negative 3 minus negative 2, negative 3 minus negative 2, which is negative 3. Negative with negative, it will be positive 2, equal negative 1. So here I will write negative 1. Zero minus 1, which is minus 1. 0 minus 0, which is 0. 1 minus 0, which is 1. So here we have leading 1, and here we have 1, and we have to make the rest of this column 0. To make here this number 0 and this number 0, so we have to add this row with this row, and here we have to add this row with this row. So we have to write row 1 here, row 1 plus row 2 to make this one 0, plus row 2 in row 1, and the same thing here. To make this one 0, we have to add this row with this row, so row 3 plus row 2 in row 3. I will speed it up to write this row because I will not change this row, so I will speed it up here. I will change the color first, then I will speed it up. So row 1 plus row 2, here row 1 plus row 2, 1 plus 0, 1, negative 1 plus 1, which is 0. Negative 2 plus 2, which is 0. 1 plus 0, which is 1. 0 plus 1, which is 1. 0 plus 0, which is 0. And the same thing here. Row 3 plus row 2. Row 3 plus row 2. 0 plus 0, which is 0. Negative 1 plus 1, which is 0. Negative 1 plus 2, which is 1. Negative 1 plus 0, which is negative 1. 0 plus 1, which is 1. 1 plus 0, which is 1. So you can see here we have leading 1, and here we have leading 1. Just here we have to make this one 0 because we have to make the rest of this column 0. Let's go a little bit down. To make this one 0, so we have to say 2 minus 2 equal to 0. So we have to multiply this row by 2. Then we can say 2 minus 2 equal to 0. So row 2 minus 2 row 3 in row 2. Let's change the color. So since we only want to change this row, so this row and this row, it will remain the same. So I will speed it up. So here we have row 2 minus 2 multiplied by row 3. Here row 2 minus 2 multiplied by row 3. So here we have row 2 here, 0 minus 2 multiplied by 0, which is 0 minus 0, which is 0. So here I have to write 0. 1 minus 2 multiplied by 0 here. So it will be 1 minus 0, which is 1. 2 minus 2 multiplied by 1. So 2 minus here 2 multiplied by row 3, which is here 1. So 2 minus here it will be 2. So 2 minus 2. The answer it will be 0. So here I will write here 0. Zero, I will write it here, 0 minus 2 multiplied by row 3, which is here negative 1. So 0, negative with negative, it will be plus 2 multiplied by 1, which is 2. Then the answer it will be 2. So here I will write 2. Here 1 minus 2 multiplied by row 3, which is here 1. So 1 minus, here it will be 2. 1 minus 2, it will be negative 1, the answer. So here I will write negative 1. 0 minus 2, which is here, 2, multiplied by 1, 0, it will be 0 minus 2, which is negative 2. So here I will write negative 2. So here we have leading 1, here we have leading 1, here we have leading 1. So here it's like identity matrix, here 3 by 3. Therefore, here we will call this one A inverse. So the answer, it will be here, this identity, and here A inverse. So you can see here we transform A here to identity. Therefore, in this side, transform from identity to A inverse. Or you can see it from here, A transform to identity, and here identity transform to A inverse. Since you can transform this one to here, then A inverse exists. Therefore, A inverse exists, and A inverse equal to this matrix. I will speed it up because I will copy it. Maybe you think that I have made some mistakes here, or maybe you ask yourself, maybe you write this, then you ask yourself, maybe I have made mistakes here. So if you think that this is not correct or something like that, you have to multiply A by A inverse, and of course you will get identity. Let's try it here. So let's try to multiply A by A inverse. If we get identity matrix, therefore our answer is correct. So let's multiply them together. So here we have A. I will speed it up. Now I will write A inverse here, because here I write here A, and here I have to write A inverse. I will speed it up. So now let's multiply these two matrices, and if we get identity matrix, therefore our answer is correct. Then we will erase everything. Just I want you to check your answer that A inverse is indeed the inverse of A. So let's multiply. So to get this element here, we have to multiply this row by this column. 1 multiplied by 1, which is 1, plus -1 multiplied by 2, which is -2, plus -2 multiplied by -1, which is 2. Now 1 here, -2 plus 2, here it will be 0, so the answer will be 1. To find this element here, we have to multiply this row by this column. 1 multiplied by 1, which is 1, plus -1 multiplied by -1, which is 1, plus -2 multiplied by 1, which is -2. 1 plus 1 plus -2, it will be 0. So here I have to write 0. To get this element here, we have to multiply this row by this column. 1 multiplied by 0, which is 0, plus -1 multiplied by -2, which is 2, 2, plus -2 multiplied by 1, which is -2. So here you see 2 plus -2, here it will be 0, so 0 plus 0, it will be 0. 0. To get this element, we have to multiply this row by this column. 0 multiplied by 1, which is 0, plus 1 multiplied by 2, which is 2, plus 2 multiplied by -1, which is -2, equal 0 plus 2 plus -2. So here equal to 0. So 0 plus 0, it will be 0. To find this element, we have to multiply this row by this column. 0 multiplied by 1, which is 0, plus 1 multiplied by -1, which is -1, plus 2 multiplied by 1, which is 2, equal 0 plus -1, which is -1, plus 2, equal to 1. 1. To find this element, we have to multiply this row by this column. So 0 multiplied by 0, which is 0, plus 1 multiplied by -2, which is -2, plus 2 multiplied by 1, which is 2. And we can see here it's equal to 0. -2 plus 2 equal to 0. 0 plus 0 equal to 0. So here we have to write 0. To find this element here, we have to multiply this row by this column. 1 multiplied by 1, which is 1, plus -2 multiplied by 2, which is -4, plus -3 multiplied by -1, which is 3. So here 1 plus with minus, it will be minus, so I will write it here again. 1 minus 4 plus 3 equal 1 minus 4, which is -3, plus 3, -3 plus 3 equal to 0. So here I have to write 0. To find this element, we have to multiply this row by this column. 1 multiplied by 1, which is 1, plus -2 multiplied by -1, which is 2, plus -3 multiplied by 1, which is -3. And you can see here 1 plus 2 equal to 3. 3 minus 3, it will be 0. So here I will write 0. To find this element, I have to multiply this row by this column. 1 multiplied by 0, which is 0, plus -2 multiplied by -2, which is 4, positive. Negative with negative, it will be positive, plus -3 multiplied by 1, which is -3. And you can see here 0 plus 4, which is 4, minus 3 equal 4 minus 3 equal to 1. So here I have to write 1. So you can see here we get to equal to identity with side 3. So here we have A multiplied by A inverse equal to identity with side 3. So our answer is correct. So now let's delete this one. So now we are sure that A inverse is correct here. As we discuss here, we have to solve the system. So we want to find this x. So here we have to find this x. Let's go back here again. So here A inverse exists. So since we have a system like this, AX equal to B, then we can multiply both sides from the left with A inverse. So this, it's look like this, A inverse multiplied by AX, here from the left we multiply by A inverse equal to, and here I want, since we multiply here by A inverse, here we have to multiply by A inverse, so A inverse multiply here by B. Therefore, as we know this here, it's equal to identity. So therefore here, then here it will be identity with side 3, of course, because we are dealing with 3 by 3. Multiply here x equal to A inverse B. And any matrix multiply by identity, it will remain the same. Therefore here, identity multiplied by x, it will be x equal to A inverse B. So x equal A inverse multiplied by B. We know that from up that the B here equal to 3, -1, 2. 3, -1, 2. So we have to multiply them to find this x. So x equal A inverse multiply by B equal, so I will speed it up to write it here, because here A inverse, I will speed it up to write it here. And here I will write B. Let's go up again. So 3, here B, 3, -1, because here B, 3, -1, 2. 3, -1, 2. 3, -1, 2. We have to multiply them together. To multiply them, we will get the solution like this. 3 by 1, because here we have 3 by 3, and here we have 3 by 1. So since this one it's equal to this one, therefore the answer here 3 1, here it is 3 1. To find this element here, we have to multiply this row by this column. 1 multiplied by 3, which is 3, plus 1 multiplied by -1, which is -1, plus 0 multiplied by 2, which is 0. So 3 plus with minus, it will be -1 equal, of course here 0, it will be disappear. 3 minus 1, it will be 2. So here I will write 2. 2. To find this element here, we have to multiply this row by this column. 2 multiplied by 3, which is 6, plus -1 multiplied by -1, which is 1, plus -2 multiplied by 2, which is -4, equal 6 plus 1, which is 7, plus with minus, it will be minus, it will be here 4, 7 minus 4, it will be 3. So here I will write 3. 3. To find this element here, we have to multiply this row by this column. -1 multiplied by 3, which is -3, plus 1 multiplied by -1, which is -1, plus 1 multiplied by 2, which is 2. So here -3, plus with minus, it will be -1, plus 2. -3 minus 1, which is -4, plus 2. -4 plus 2, which is -2. So here I will write -2. -2. So here our answer, x equal to this vector. So x equal to 2, 3, -2. Therefore, the linear system which we called it ax equal b has a unique solution. X equal, and we know here x, it represents x1, x2, x3. So x1, x2, x3. As we discussed here, x1, x2, x3, which represent this one, equal, this is our solution here. We find 2, 3, -2. 2, 3, -2. So that's it here. We found the solution. So now let's check even here. Let's check our answer that this is the solution. So I want to cut it here. I want to copy it, not cut it. I want to try to substitute it here. Here, the solution we got. So here we have x1 equal 2. So here x1 equal 2. x2 equal 3. x3 equal negative 2. Negative 2. So let's try to find this answer. So 2 minus 3 minus 2 multiplied by negative 2. Minus with minus, it will be positive. So here positive. 2 multiplied by 2, it will be 4. 2 minus 3, it will be negative 1. Plus 4. And this equal to negative 1 plus 4, it will be 3, which is 3. So this answer, it looks like this answer. And the same thing here. If you substitute here, x2 equal 3 and x3 equal negative 2, you will get 3 minus 2 multiplied by plus 2, it will be minus 4. 3 minus 4, it will be minus 1. So here, the same here, minus 1. And the same thing here for this row. You substitute here equal 2. You substitute here equal to 3. And for x3, you substitute negative 2. Negative 2. So here it will be 2 minus 2 multiplied by 3, which is 6. Minus, with minus, it will be positive, because minus multiplied by minus, which is positive. 3 multiplied by 2, which is 6. And the answer here, 6 with 6 equal to 0. 2 minus 0, the answer will be here too, the same as here. So we have confirmed that our answer here is correct. I want to erase this now since we confirm it. So you can see how to confirm our answer. Every time we can confirm it. Of course, if you want to confirm it, if you have more time in the exam or in the homework or anything, you can do it, but just to confirm your answer. Also, you can confirm it by using, for example, MATLAB or Python or any program in the internet. That's it here. So we find the inverse and we find that the linear solution has a unique solution. So we finish this one. Now let's solve number 2. Let's go up to find the answer of this one. So we want to find the inverse of this C. I will copy it here. I will write it down. So we want to find the inverse of this C. So here our C. As we did before, we have to write it in the augmented form. So it looks like this. I will write here C. And here I will write identity with size 3, because here 3 by 3. Then I will close this bracket. Just I copy it here because I want to copy it here. So here is C. I will write here C. 0, 1, 2, 0, 1, 1, negative 2, 2, 2. And I will write here the augmented matrix line. Here the line of the augmented matrix. Then I will write here identity with side 3 by 3. So 1, 0, 0, 0, 1, 0, 0, 0, 1. Now I will erase this matrix. Now I will close this bracket. Then I will write it like this. Since here we have to make this number equal to 1, because here we have to make it, as we discussed, to make it like identity matrix with size 3 by 3. We have to make it like this. To make this side like this side, we have to make it. So here it has to be a number, then we have to make it 1. So here we have -2. So we have to change this row by this row. Then, of course, we have to make it here this number equal to 1. You can do 2 steps just in one time, so you can change row 3 by row 1, then you divide this row by -2. So you can do it, but I prefer to do it step by step. Let's delete this one. So row 3, I will exchange it with row 1. I will change the color. So since we will not change anything in this row, so I will speed it up to write this row first. So I will change this row by this row. So here, -2, I will write it here. -2, 2, 2, 0, 0, 1, 0, 0, 1, 0, 1, 2. So here, 0, 1, 2, 1, 0, 0, 1, 0, 0. Now I have to make this number equal to 1, so we have to divide this row by -2. So divide the first row by -2 in row 1. I will speed it up to write this row and this row. So we have to divide the first row by -2. So -2 divided by -2, it will be 1. 2 divided by -2, it will be -1. 2 divided by -2, which is -1. 0 divided by -2, which is 0. 0 divided by -2, which is 0. 1 divided by -2, which is -1/2. Here we have leading 1. Here we have leading 1. So we have to make the rest of this column 0. So we have to make this one 0 and this one 0. So we have to add this row with this row to make it 0 here, because -1 plus 1, it will be 0 here. And here we have to subtract this row with this row. So 1 minus 1, it will be here 0. So the first row plus row 2, this row plus row 2 to make it this one 0 in row 1. And for the third row, we have to subtract it with the row 2. So 1 minus 1, it will be here 0 in row 3. Since I will not change anything with this row, so I will speed it up to write this row. So we have to add row 1 with row 2. So 1 plus 0, which is 1. -1 plus 1, which is 0. -1 plus 1, which is 0. 0 plus 0, which is 0. 0 plus 1, which is 1. -1/2 plus 0, it will be the same, -1/2. Now row 3 minus row 2. So 0 minus 0, which is 0. 1 minus 1, which is 0, 2 minus 1, which is 1, 1 minus 0, which is 1, 0 minus 1, which is negative 1, 0 minus 0, which is 0. As you can see here, we have here 1, here 1, here 1. So here we have to make this number equal to 0. So we have to subtract this number with this number to make this one 0. So row 2 minus row 3 in row 2. I will change the color. I will speed it up because we will not change this row and this row, so I will speed it up to write them in very fast way, to write this row and this row. So now here, row 2 minus row 3, so 0 minus 0, which is 0, 1 minus 0, which is 1, 1 minus 1, which is 0, 0 minus 1, which is negative 1. Here it will be a negative 1 because 0 minus here 1. Since here 0 minus 1, it will be negative 1. So that's why I wrote it here negative 1. Here 1 minus negative 1. So here 1 minus negative 1. It will be 1 plus 1 because negative with negative it will be plus. So the answer it will be 2. So here I will write 2. 0 minus 0, which is 0. I will delete this one, so I will write it exactly the same as here. So I want to move it to here, so I will delete it. So here 0 equal, and here we have identity with size 3, and here we will get the C inverse. Here we have identity with size 3, and here we have the C inverse. As we begin here we have C, here we have identity with the size 3. So we start from C and we end with identity on the left side, and the right side we end from identity to the C inverse. And you can see we start from here the C, we end with identity, and here the side identity to the C inverse. So that's it. And the same thing, you can confirm your answer by multiplying the C by C inverse, but I will leave it to you to do it. I will change the color. Therefore, C inverse exists, and C inverse equal C inverse is here. I will speed it up to write the C inverse, so I will copy this one here. Since we have Cx equal to 0, if we go up, we can see that we have Cx equal to 0. They want to find the solution, so we have to multiply from the left with C inverse because it exists, so we can multiply from the left C inverse. So therefore we can multiply by C inverse from the left, so C inverse multiply by C x, here Cx, here the same here Cx equal, since I multiply here by C inverse here, so here I have to multiply by C inverse, so C inverse and here 0, and we know that, I will change the color, this side, C inverse multiplied by C, we know that it's equal to identity. So here I will write identity. Of course, with size 3 because it's 3 by 3. And here I will write here X equal C inverse multiplied by 0, which is 0. And we know that any matrix multiplied by identity, it will remain the same. Of course, it has to match the size as well. So here, the answer of this one, it will be X equal 0. So the solution we have this. Since we have X equal to 0, and of course C inverse exists, therefore you can see that the solution here, it's unique because it has X equal to 0, not infinitely many solutions. You can say from here, since C inverse exists, then it has a unique solution, or you can do it like what we did. So this is, you will get a full mark if you do like this. So you will get here X equal to 0. So here it's only a solution that X equal to 0. So you have to say that here the question, does the linear system Cx equal to 0 have infinitely many solution? So you have to say no, it does not, because you will get a unique solution, not infinitely many solution. And you can say a unique solution or a trivial solution, but it's not infinitely many solution. So we will say that no, it doesn't. No, it does not have infinitely many solutions, or they called it non-trivial solution. So therefore the linear system Cx equal to 0 has a unique solution, or you can say trivial solution. And here X equal to x1, x2, x3 equal to 0, 0, 0. And of course you can say the 0. That's it here. We find for this solution that it has a unique solution. We can go up. So for both these questions, they have a unique solution. Since here A inverse exists, therefore the system here, it has a unique solution, which we say that X equal to 2, 3, negative 2. So the solution for here, this X, it's equal to 2, 3, negative 2. But for the solution for this here, because since it's a unique solution, so it has only X equal to 0. So all x1, x2, x3, they are 0. As you can see, it takes a lot of time to find the inverse of these 2 matrix here because they are 3 by 3 matrix, but you can solve it by another way. Instead of RREF, reduced row echelon form, as we did in this video, you can also find the inverse of a matrix by finding the determinant and adjugate, or they called it adjoint, of the matrix. It's easy to figure out if the inverse of a matrix exists if you compute the determinant, which we will see it later. So later we will see it in some videos. Feel free to comment below if you have any question or suggestion about this video. So see you in the next video.